Welcome to Let's Talk Value Chain, a podcast where we explore the different activities, trends, topics, and components within value chains from manufacturing to impacts on supply chains to AI to blockchains.
Welcome to another episode of Let's Talk Value Chain. Today, we have Dalraj Nijjar, the co-founder and chief commercial officer for Concrete4Change, multi-award winning company that's aiming to mitigate 2 billion tons of CO2 emissions in concrete industry by 2040. We speak to Dalraj about how this innovative technology is aiming to do this and the different aspects of value chain that they are impacting through their innovation. Hi, Dal. Welcome to our podcast, Let's Talk Value Chain. It's great to have you here. Would you mind introducing yourself to our listeners?
Sure. Thank you for having me, Nishant. Hello, everybody. My name is Dalraj Nijjar. You can call me Dal for short. So I am the co-founder and chief commercial officer of Concrete4Change. And we're a company that is developing technology to essentially make concrete into a very safe and scalable carbon sink. Yeah. And so in doing so, we can help solve hopefully some of the world's emissions problem in doing so as well. So yeah, I look after anything on the commercial side and the business side of the company. We're primarily R&D focused. So we're developing novel approaches for how we can essentially lock CO2 into concrete, which I can get into. But yeah, it's great to be here, and I'm excited to share about what value chain means to us and how it can maybe inspire others as well.
Awesome. And before we get more detail about what you're doing today, how did you get inspired to join Concrete4Change, and where did it all start?
So I joined Concrete4Change in December of 2021. So as a bit of background context, as you will know as well, Nishant, I was at Warwick Manufacturing Group, which is a department at the University of Warwick. And during my time there, I was one of the founding members of a startup accelerator, whereby we were helping a number of different startups and also some bigger companies, bigger SMEs as well, who were working in different supply chains, in industrial sectors, in climate tech, a wide variety of different companies in different sectors. And my role in particular was looking at how they can examine potentially new markets, how they could improve product market fit, how they could see opportunities, blue oceans, if you will, and try to optimize their business model, at least on paper, so that they can then go and start to implement changes necessary to de-risk how they think they can scale up their technology or their company. So during my time there, I learned a great deal, trying to come up with strategies that tailor-made to help these companies, because as you all know, no one startup is the same. Each startup is working on a slightly different problem or has a slightly different approach. So, where typical accelerators would take a cookie cutter approach and apply the same tool bluntly to everybody, we tried to tailor it as much as we could to get the maximum value out of it possible and help that founder think about what they're doing better. And that's essentially what we try to do. So, during my time there, I got a really good kind of network and kind of handle on what the startup ecosystem was in that area, in the university and even in the region to some degree, I would say. And so the two first founders of Concrete4Change, Dr. Sid Paul and Dr. Michael Wise, they were doing some proof of concept tests at the civil engineering department at Warwick University. And because Dr. Sid has a very good friend called Professor Reyes Garcia, who's also a professor at the civil engineering department. So I got wind of what they were doing. And yeah, I'd be lying to you if I thought I'd be working in this kind of industry. I didn't anticipate it. But when I got to know them and I got to understand the dynamics of the concrete industry and the solution that they had, the proof of concept that they had at the time, which I can go into in more detail, it was really exciting in terms of this could really change the game in the industry. Yeah. And as I say, create or make concrete into a very safe carbon sink, which no current technology has really done at the scale that it can be done. And given their more engineering and technical expertise, my kind of more commercially focused expertise created a nice balance. And so from December 21, I kind of started in a more part-time capacity and then quickly became full-time and a co-founder and chief commercial officer. And then from there, we've just, in some ways slowly, but also very rapidly kind of scaled up in terms of people, in terms of investment, in terms of our R&D capability. And so now I'd say we're quite well established as one of the kind of up and coming technology providers for helping the entire industry decarbonize over time. So that's a bit of background.
Okay. So that's very interesting to know how you got into this. And so tell us more about, what are the key aspects within your value chain and, the innovation that you guys are working on?
We are a little bit of a unique case in the grand scheme and grand landscape of the push towards decarbonizing cement and concrete. So we are essentially what I would call an advanced materials and CO2 utilization company. And so what that means is, in terms of our technology, what we're trying to do is we're developing a number of what we call carrier materials. And these are essentially meant to be additives which are specifically designed to have very high CO2 capacity. So if you take, let's say, 1 gram of our material, anywhere between 20 to even up to 50% of its weight is CO2. And so we then look to mix that material as a small additive in a cement or concrete mix. And then the idea then is that our material, once mixed into the cement mix, into the concrete, will start to release CO2 from its structure. And as it's releasing CO2, that CO2 then starts to mineralize within the pores and areas of minerals within the cement in particular. So again, the two get mixed up. For those who don't know, cement is like the glue in concrete, if you will. It's typically around 10 to 15% of concrete by mass, but it's the most important material, if you will. It's the binder. It binds everything together, like so the sand, the aggregates, water, the other components are binded together by the cement. But cement has a very potentially high capacity for absorbing a lot of CO2. So the theoretical maximum is 30% weight CO2 for cement, but no one's ever close. And there's lots of challenges to get to that. It's not very easy. It's a very, very hard chemistry challenge. But the approach that we're taking is, if we can add our material as an additive and release that CO2 within the cement, so there's no leakage before or after, then the cement has the maximum opportunity to absorb that CO2 and create, essentially, in very simple terms, these very stable forms of calcium carbonate crystals, which basically make the concrete more dense. And if you do that, that makes the concrete stronger. And so if you make concrete stronger, that actually means you need less cement in the first instance to create the equivalent strength grade of concrete mix. There's already defined strength grades. You don't really need the extra strength.
Yeah.
And so what that means is, if we do that continuously and accurately every time, that means, number one, we're permanently removing CO2 within the concrete. So that means that, let's say, for example, that concrete is used for 40 to 100 years, and let's say you demolish it at the end of life, that CO2 won't leak. So the only way it would leak is if it's heated up to like 800 degrees, which is not going to happen in real life. And also as well, if you can reduce your cement content as well, let's say by anywhere between 10 and 20% because of the strength increase we can create, that means that actually we're avoiding emissions as well, because for traditional types of cement, or Portland cement, or cement type 1 as it's known, otherwise, for every kilogram of cement you produce, you're looking at nearly a kilogram of CO2 emitted. So that's got quite a big impact. And so what that means is we're a company that is trying to take the CO2, ideally, from when cement is produced. So when cement is produced, typically a lot of CO2 is produced because one of the key inputs is limestone in terms of making that cement material. And when you burn limestone, you essentially liberate CO2 from that structure of the material. And so as a result, cement is one of, if not the hardest to abate industry probably in the world. However, with that CO2 that they're producing from their flue gases, we can utilize that, use that as feedstock for creating our carrier material. And then subsequently, our carrier material can lock away that CO2 into the cement component of the concrete. So it's creating almost a little bit of a circular approach. And in a weird way, kind of almost creating like a synthetic limestone again in the concrete. We see ourselves as almost like a partner to the cement and concrete manufacturers, who will be our customers, but ultimately a partner, because they make cement and concrete very well, but they haven't been able to come up with the innovations to obviously decarbonize quickly enough. So, we're looking to be one of, if not one of the top solution providers in this particular area. Our focus is very much on the research and development of these carrier materials. So trying to take ideally, again, waste as precursors. So let's say this could be a waste wood, or it could be a waste polymer, as two easy examples. And then with that precursor, we then as a company come up with different formulations of these materials. So we'd modify them, we'd change the size of them, we'd add certain chemicals, all with the purpose of how can we absorb the maximum amount of CO2 within this material by weight. So within that, let's say 20 to 50% by weight zone. And then how can we then get this material to release CO2 into cement in the way that we want it to, so that we can carbonate the cement, i.e. remove that CO2 and increase the strength of the cement in the concrete. And so it's very much a chemistry focused approach to the challenge of trying to put CO2 into concrete, because the approach that has been taken so far by the industry and by other technologies as well that we're competing against has been thinking of it as an engineering problem, and it's not, because putting CO2 into cement is a chemistry problem, because there's multiple wrong ways of doing it, which would actually ruin your concrete, which is obviously not what we want to do. We want to positively impact it. We want to make it stronger. We want to make it more mechanically better, et cetera, et cetera. And how you do that, there's only a few right ways to do. And so we're trying to optimize for that. And so just to close off at this point, we see ourselves as an IP-driven licensing company in the main. So we, in terms of the value chain, we would be the IP holder, and we would work with third-party, in the early days anyway, we'd work with third-party production partners who could produce material on our behalf, because they they should have the kind of, the capability in place to produce such a material. They don't at the moment, but they would do that on our behalf. And then our material would be sent to a concrete manufacturer at their production site. And then, again, one of the key USPs of our technology is they just mix it in their concrete as a small additive, and that's it. They forget about it. There's no real change to their production lines. There's no change to kind of their capex on site. It's a very traditional and conservative industry that doesn't like changing. So the less variables you can change, the better. That's kind of one of the key components or key USPs of our approach as well. It's easy to adopt and highly scalable once we get to slightly higher TRL. So hopefully that makes sense.
That's absolutely fascinating. And again, not coming from the industry myself, it's interesting to understand some of the dynamics and some of the innovation aspects in that area, which again, linking back to emissions and carbon footprint and net zero, which everybody is interested in. I mean, and you talked a little bit about that in terms of some of the challenges that you face when scaling something like this. Is there anything else you would like to add on in terms of, when you are building this type of technology today, apart from the fact that, you're trying to do something to a concrete without negatively impacting it? Is concrete the only material that, you would be doing this for, or your innovation could actually go into, the bricks or any other building material that might be utilized?
Yeah, it's a good question. We haven't explored other building materials in great depth, but I don't see any reason why not. And it's definitely something that probably would be on a little bit of radar for sure. I would say the other area that we are also intersecting with is carbon capture. So, you have advancements in direct air capture, for example, whereby, you have companies like Climeworks, who are probably the best example, who are essentially trying to pull CO2 out of the air and using solvents to do so to capture that CO2, and then they would then release that CO2, whether that be underground storage or, trying to utilize that and create products from it, or certain chemicals. We are also very much intersecting with that industry in that sector. And so, for example, some of the materials that we're developing in the very, very long term, they could also be used for such direct air capture as an approach for them as well. Although that's, again, a very much more long-term view, depending on how things develop. That being said as well, the cement industry, again, for people who are maybe not so familiar with the industry, it produces roughly 3 billion tons of CO2 every year. And what the main approach is to solving that is carbon capture and storage underground. So a lot of the publicly listed cement manufacturers in UK and Europe, for the most part, trying to implement various technologies that can capture CO2 point source from their cement flues, and then they're going through various stages of purification, pressurizing that CO2, making it stable enough so that it can be transported via pipeline or other means, so that CO2 can be injected underground somewhere, where typically there used to be an old oil well or under the sea, for example. And so that requires a lot of investment, both in terms of capex and opex, and that investment obviously has to be paid for, right? And given that cement and concrete is already a fairly low margin commodity business, that's going to be passed on to the customer. And so cement and concrete prices in all likelihood will probably go up. Whereas what we're trying to do is negate that cost primarily from the capturing point onwards, so that, okay, let's say you have your CO2 that's captured, Mr. Cement Manufacturer, let's do something with it. So, they can give it to us. And whilst I'm not saying that we can take all those 3 billion tons of CO2, as much as I'd love to, we can take a very small portion in the very early days and make more material from it. And then they can then implement that in their cement and their concrete afterwards. So it's one of the few, if not only, approaches for utilizing CO2 into concrete. Other industry areas you can go into in the long term are numerous. I would say anything involved in CO2 utilization and creating products and chemicals that have that CO2 as a feedstock, it is right in our area, I would say, in terms of our competence. In terms of core focus right now, it should be concrete and probably will be for a very, very prolonged period of time. And the reason why I say that is because the problem is there, but also it's a massive, massive market. I think the stat I read the other day was for every person in the world, we're using 5 tons of concrete per person, which is crazy, right? Particularly in the more developing areas of the world. Producing a lot of concrete and using a lot of it. So, it's still the most trusted and safest building material, despite its emissions problem. That will continue to be the case for a very long period of time. So, any advancements in making it more sustainable, but also not making it too expensive in doing so, will be put forward and brought to the front. And we're trying to be one of those. It's a blend of, in our case, you have cement and concrete manufacturers that are well versed in making cement and concrete, and that's what they do. There's a really big chasm, which is hopefully being fulfilled by us very soon, in terms of the R&D and innovation capability to help them to decarbonize in our way. Right. So there are other technologies out there. Let's say, there are others that are, let's say, trying to take waste concrete and upcycle that, which is an interesting development. I think that's got quite a lot of potential. You've got other companies that are trying to make other types of cement, which again is interesting, but there typically is scalability issues with that. Depending on the type of cement, the new type of cement you make, you have very, very long regulatory timelines. So, there's challenges in each vertical, but there is this gap that needs to be filled, and we're trying to be at the front of that queue. So all that being said, there is plenty of opportunity in this industry to make a big difference, but it takes a lot of collaboration. It takes also kind of a shift in mindset as well, because these legacy industries have kind of done things the way they've done things. Nothing's really changed. So to shift that mindset to more of an R&D mindset is not so easy. There are companies out there that have that already, and a few which we're working with, which I'll talk about later. But like with any industry, you have these kind of early adopters, right? You have these early adopters that kind of show the way, and eventually the rest follow. It just so happens there's probably more laggards in our industry compared to the other industries that we're familiar with.
No, absolutely. And I think, it's good you mentioned, there are other technologies and opportunities and other ways of doing something similar result that people are trying to do. Is there any specific emerging tech that you're seeing, either assist you or create a threat for you? So the likes of, artificial intelligence to help you come up with any of the chemistry, or, or general, just, any other concrete trends or other, recently I came across somebody who is doing self-healing concretes as well. So anything like that you see as, opportunities or threats or disruptors to yourselves?
Yeah, it's a good question. I think in my opinion, this is just my opinion, I don't see it as threats per se. I would, again, whilst I will admit I am slightly biased, I would say that we are the most advanced company in terms of technology, in terms of the approach by far. That's across all verticals. And the reason why I say that is because we've taken a very different approach to the problem. As I kind of alluded to earlier, the majority, or pretty much 99% of other companies apart from us, have approached this as an engineering problem, which has some benefits for sure. And it does create emissions reductions, but there are limitations in terms of scalability of that. Particularly, let's say, if you take one of the key examples is there are companies that are developing what are called supplementary cementitious materials. In layman's terms, what that is basically the cement industry takes waste byproducts of the steel production industries and the coal production industries, and then uses that as a substitute for traditional cement. And because it's a waste byproduct, it's therefore classed as a cleaner, greener material. But the problem is that those materials as waste byproducts can only satisfy 5% of the demand for cement in the world. And that's the maximum. And they're running out because, the types of, let's say, coal production, particularly in Europe, is switching off. So you don't really have that. And the amount of steel that's produced, or traditional steel that's produced, is also changing. So there's scalability problems there. Then you have other technologies that, let's say, for example, we're in our wheelhouse of how we mineralize, how we lock CO2 into concrete. But, for example, they'll just take a CO2 gas and just spray it onto a wet concrete mix. And it doesn't take a scientist or a chemist to realize when you spray something, it can evaporate. Yeah. So there's issues there. And then there's other technologies whereby, for example, they'll take a pressurized chamber, and you could take like a concrete block and then put that in the chamber to cure CO2 around the outer layers of it. But the majority of concrete that's used in the world is what's called ready-mix concrete. So that's concrete that's, let's say, comes in a big truck. You see those concrete trucks, those mixer trucks, and they just literally pour it into a ground somewhere to make a pavement or make part of a road or whatever it might be. So again, that chamber-based approach is only applicable to, I'd say, no more than 10% of all the applications of concrete in the world. You can't make that with a bridge, right? I'm not saying that we have all the answers and we're all singing, all dancing, but what I would say is that we have the highest scalability potential. I would say that we are the easiest to adopt by far, and we have the most applicability to any cement and concrete mix. There's no limitation. It literally could be used a bridge, skyscraper, a road, a pavement. There's no theoretical limitation. For us, it's a case of how we scale up to those quantities, right? In the very long term, it would have to be something like creating production plants of our own, right? And that's a whole different ballgame in terms of obviously manufacturing lines and how you optimize that. As I'm sure you know, as an expert in this field, those supply chains and manufacturing lines can be very, very complicated to set up in the early days. But that is it's emerging. It's on the horizon for us, for sure. And so there is space for all of these technologies. Don't get me wrong. That I'm not saying that there's going to be a winner takes all. But what I do definitely think will happen is there's going to be a blend of 2 to 3 solutions which come to the top and take the market share. And they're going to be in any of these 3 verticals, in my opinion, again, just my opinion as someone who's in this industry, which is the first vertical, which we're in, which is utilizing CO2 in concrete. I'd say, we're trying to be number 1 here. Then second is anyone that's trying to help decarbonize cement, whether that be a new material, like as I say, a supplementary material, or it could be process efficiencies at the, let's say, cement kiln level when you're making cement, making them, cleaner or greener, for example. And I think the third area, which is really interesting, is recycling end-of-life concrete. So the sad fact is the majority of demolished concrete goes to landfill, which is a shame, right? If we could actually recycle that, or what's called upcycle that, technically speaking. So that you don't need to dig up as much cement, or let's say the raw materials for cement, and subsequently, let's say, aggregates as well from the ground. You can, that's good. So those 3 verticals are what I see to be the highest potential. Can make the biggest impact in terms of emissions reduction, but also be cost effective in the long term as well. So that's how I see the landscape at the moment.
No, that's very interesting. I think it's, again, good to understand that, the breadth of this as well. So, you touched upon this a little bit earlier about partnerships, right? And, things can't be done on your own. So could you elaborate a bit more about partnership and collaborations that, you've utilized and building upon to actually, scale and create the type of impact that you're trying to create?
Yeah, for sure. So we work very closely with 2 very large concrete manufacturers. The first one is Goldbeck. So they are the largest producer of precast concrete in Europe. So they're a German company, a leader in their area. They create a number of different basically buildings, or let's say parking lots in particular in the UK, multi-story commercial buildings as well in Europe in particular. And so they create precast concrete in their production lines and their factories all across Germany, the Czech Republic, Netherlands, and a few other areas in kind of Western Central Europe. So they produce around 500,000 cubic meters of concrete per year, which for people who don't know cubic meters, that's roughly, if you times that by about 2.5, that's the tonnage equivalent. So they will be our first adopter of our technology. They are a very, very forward-thinking manufacturer, and that's driven by the kind of the management leadership mindset of trying to innovate and be more sustainable. So they've really supported us from day one, really. In the very early days, when we had just a proof of concept, they saw the potential in what we were doing. They examined existing approaches for mineralizing CO2 into cement and concrete, and they're very much in the market. They're making money, they're making revenue, they're well-established approaches, but there's limitations there. But they could see that our technology could get over those limitations, even though it was very, very early days at the time. So we've worked very closely with them over the last 2.5 years, looking at how we can fit into their production lines, how we can create a material that makes sense from the unit economics point of view, so that there is a business model that works for us and for them, how they would think about or utilize the emissions reduction that they get. So, for example, one of the main business model based opportunities of doing this kind of carbon removal and mitigation is that you can sell carbon offsets to, let's say, a big corporate, or you can sell them on an open marketplace, for example, which existing competitors of ours do at the moment. But in Goldbeck's case, they don't want to do that, right? They want to reduce their own emissions internally, which makes sense. So things like that have been really, really helpful from our point of view of how we can de-risk our market entry approach, and how we can think about scaling commercial potential as well. And as well, we've had a number of trials with them over the last 2 years, primarily at the lab scale, but soon to be at the pilot the industrial scales of material in their concrete mixes. And so they've been a really, really supportive and great partner, and we're looking forward to keeping that going. The second partner that we work closely with is Siam Cement Group. So this is one of the largest cement and concrete manufacturers in the whole world. It's a leader in Southeast Asia. So anywhere apart from Japan and China, it's number one. So you take primarily it's Thailand, Cambodia, Laos, Vietnam. They are the leading cement and ready-mix concrete manufacturer. Similar story as to with Goldbeck. They looked at existing technologies in great depth. They didn't proceed with them, and we got in contact with them, and as I say, showcase what we could do and what the potential was, and again, they were very, very supportive in the early days. So they have really, really good appreciation of the market landscape as well, in terms of that piece around carbon capture and storage, which I mentioned about, sustainability and commercial implications of that, and all the way to the end in terms of, okay, how is concrete used on a day-to-day basis? What's the kind of price sensitivities in that area of the world versus how it would be in Europe, because the dynamics are a bit different. For example, there's carbon tax in Europe, there's no carbon tax in Southeast Asia, so that makes a difference. And just providing that intel as to how we can tailor our approach, what other technologies are out there which they're considering, but how we should then approach how we enter the market and how we work with customers like Siam and others. Whilst we haven't done as many trials with them as we have with Goldbeck, given the distance, because obviously they're based in Thailand, it's a little bit tricky for us. They're going to be an early adopter, and we're really looking forward to scaling up with them, because they are massive, absolutely huge in that area, and a really, really well-respected publicly listed cement manufacturer, like one of the ones at the top table, basically, if that makes sense. So to get their buy-in and get their name next to our name has been really helpful from the earliest days. Because in an industry like this, which is more conservative, right? When you're a new entrant, you're a new startup, you're an innovator, you have to legitimize your presence, right? Not just through technology, but through partnership. So to have those two companies' names next to ours has been really, really helpful from that point of view. And it helps say that, okay, to people who don't know us, they think, okay, there's something to this, right? And it's not just me saying it, it's these, the leadership of these teams are backing us. So, if you want to believe me, you can talk to them.
I think, you need those partners and collaborators to, which shows that it's not just an internalized thing. There's a genuine appreciation for that. And when some of these existing well-respected companies come on board as well, I think I can validate that, which, is a great thing to do. So we're coming to the end of our podcast. Is there any parting wisdom you would like to share with the listeners, and how, if they wanted to follow up with you, how can they reach you?
Sure. I think closing thoughts from me, from our industry's perspective is, and maybe this is applicable to others, is I would call for patience. Obviously, the emissions problem is quite stark, and I'd say in the public domain, depending on who you speak to and the vantage point they have, some can be quite, let's say, they can kind of approach it almost like it's doom and gloom, like there's an existential threat here, which I would say is a little bit overplayed, because there are lots of developments, not just in our industry, but in other industries where the emissions problem lies, where there will be a big difference coming soon. So I think it just requires time, it requires investment, it requires patient R&D to get these legacy industries in particular to move in the right direction, which they are.
Yeah.
So I think the emissions problem can be solved. It's just going to take longer than what people think. And which is obviously not the headline that most people want to hear, but I think eventually we'll get them. Also as well, kind of teamed into that to do it in a cost-effective manner, because that's also a key driver. If things are too expensive, it's just not going to be adopted. So there has to be routes forward for costs to be driven down and there to be scalability there, because again, scalability is the way to solve. So yeah, hopefully that can apply, those principles can apply to maybe what other people are working on. And yeah, in terms of how people can contact me, you can connect with me on LinkedIn, so Dalraj Nijjar, feel free to add me on there. And yeah, through our website as well, Concrete4Change.com, feel free to drop a note that will contact us. More than happy to connect with anyone. And yeah, we're happy to support other people developing really interesting technologies that can help us decarbonize and do so effectively as well. So yeah, I'm looking forward to connecting with everybody.
Thanks for that, and thanks for sharing your insights and your experience with Concrete4Change and what you guys are doing with the innovation there as well. Hope you enjoyed this episode and found our discussion intriguing and exciting. If you want to connect with me or any of our guests, you can see our content and connect details in the summary of this episode. This podcast is sponsored by Value Chain. Value Chain is a leading B2B SaaS platform for intelligent collaboration, performance management, net zero supply chain identification, risk and resilience building, and a platform to help you manage your local and global supply chains.